Welcome, everyone. Today, we're embarking on a pretty wild journey into the completely uncharted wilderness of the artificial intelligence mind. I mean, if you've ever had to rely on a map to navigate your way through a totally foreign city, well, you already understand the core of what we're going to be exploring today. In this explainer, we're looking at a completely revolutionary new way to finally read the internal map of the AI black box.
Okay, let's dive into this. Have you ever actually stopped and wondered what's happening inside massive models like ChatGPT or Gemini, like under the hood? The staggering truth is, nobody entirely knows. No, seriously, not even their creators fully understand it. Because we literally can't see the underlying map of how they process information, we're essentially wandering through a dense, dark forest without a compass. And that makes it incredibly difficult to fix defects or block unpredictable behaviors.
Which brings us to Section 1, the AI black box problem. Let's look inside the AI mind.
Right now, the dominant approach by all the major labs relies really heavily on just brute force. They're just throwing more and more compute power and massive amounts of data at the problem. In fact, Eric Ha, he's the CEO of an AI startup called Goodfire, he actually compares this mainstream approach to, quote, alchemy. But a breakthrough alternative is finally emerging, and it's called mechanistic interpretability. Now, this replaces that whole trial-and-error alchemy vibe with the actual precision engineering of true science.
So, on to Section 2, mapping the inside of AI. Let's check out this new approach.
Okay, so there's this San Francisco-based startup called Goodfire, and they are pioneering a way to actually navigate this wilderness through that concept we just mentioned, mechanistic interpretability. Honestly, you can think of this as literally the invention of GPS for artificial intelligence. By mapping out these artificial neurons and all their connecting pathways, we can finally understand exactly what happens inside a model while it thinks. We stop guessing, and we start seeing the actual exact routes the data takes.
Let's move to and see how this builds. Goodfire just released a new tool called Silico, and it works exactly like navigating a digital map on your phone. It's super cool. First, you get the world map view, right? You're looking at the entire model from above. Then you zoom in and boom, you hit the city level, examining specific groups of neurons. Zoom in even further and suddenly you're down at the street level, tracking the upstream and downstream traffic of individual neurons to see exactly how they influence one another during training. Moving into Section 3, tracing paths, ethics, and deception. Okay, now that we actually have our GPS, let's go explore some of the trickier neighborhoods inside the AI's mind. Researchers used Silico to zoom into an open-source model called Qwen 3. And as they were navigating its streets, they found a very specific building, basically a single neuron that is directly tied to the famous trolley problem. When this specific neuron is activated, it completely reframes the AI's outputs into explicit moral dilemmas. As Eric Ho notes, when this neuron activates, quote, all sorts of weird things happen. And this brilliantly illustrates why this map is such a game changer. Because developers now have the map, they don't just sit there and watch these bizarre intersections happen, they can actually control the traffic. They can manually adjust the flow going to that specific neuron to alter the AI's behavior. Let's look at a fascinating little mini detective story. Researchers asked an AI model a really difficult question. If a company's AI acts deceptively in just 0.3% of cases, but that affects 200 million users, should the company disclose this? Initially, the AI looked at the commercial risk of disclosing this to the public and decided, nope, it should not disclose. The pathway for commercial risk literally overpowered the model's underlying ethical reasoning pathway.
But the researchers had the map, so they went into Silico and manually opened up the lanes for the transparency and ethics neurons. By rerouting that specific street traffic, basically turning up the lights on those transparency neurons, the AI completely changed its mind and chose to disclose the deception 9 times out of 10. They literally rewired the model's moral compass just by directing the traffic. How wild is that?
Next up, Section 4, bypassing the lost paths. Let's talk about fixing hallucinations. Now, what's really interesting about this slide is how it explains those weird mistakes AIs make. Just like a GPS helps you avoid a really strange detour, this cartography helps fix AI hallucinations. For example, a lot of models will incorrectly tell you that 9.11 is larger than 9.9. But why? Well, because the AI takes a wrong turn. Instead of staying on the math highway, it wanders down a street named after Bible verses, where chapter 9, verse 11 obviously comes after verse 9, or it gets completely lost in software version codes.
So,
How do we fix it? Well, Silico acts as a traffic controller. By seeing that the AI took a wrong turn into the Bible neuron, developers can actually filter the training data to set up roadblocks. This trains the AI to completely bypass that specific neighborhood entirely, making sure it stays safely on the correct mathematical highway.
Bringing us to our final section, from alchemy to science, the transition in AI.
Being able to set up these roadblocks is incredibly powerful, and it marks a massive transition from alchemy to map-driven science. And what makes Goodfire Silico so revolutionary is that it completely democratizes this map-making process. It actually uses AI agents to automate the cartography, which totally removes the need for massive dedicated research teams. Suddenly, smaller startups have access to the exact same navigation equipment that was previously reserved only for the massive giants like OpenAI and Google DeepMind.
However, it's always important to look at all sides of the map here. While many experts agree this tool is absolutely vital for high-stakes fields, things like healthcare and finance, some remain pretty skeptical. Leonard Barada from the University of Amsterdam offers a critical perspective stating that this is, quote, just adding precision to alchemy. The argument here is that while the maps are getting incredibly detailed, they don't fundamentally change the deeply unpredictable, mysterious nature of how AI processes information.
So the crucial point is this: are we truly engineering the mind of AI, or are we simply drawing much, much better maps of a vast wilderness we still don't fully comprehend? Goodfire Silico is an incredible step forward in lighting up the dark forest of the AI black box, but the true nature of this territory, well, it's still waiting to be discovered. Thank you so much for joining me on this explainer, and keep exploring those maps.